Hello, everyone. Welcome to this pre-conference webinar. We're going to have a very interesting presentation today with Suman. But before that, I just want to give you some context for the ones who haven't been here in one of our webinars. I want to explain a bit why we're doing this, what's objective, and where we're heading to. So welcome, everyone, for the ones looking at this live stream in LinkedIn Live or in YouTube, in the Selenium Conference YouTube channel. Welcome. We're doing this because very soon, in less than, I think in about 40 days, we're doing a conference. The Selenium and Appium conference are happening together here in Valencia. I'm based in Valencia, so that's partially why we're doing it here in Valencia between the 26th and the 28th of March, this 2025. So in around 40 days, we're going to be having the conference here. We have a great agenda. We have a wide range of topics. We are going from obviously AI, one of the biggest topics in the conference right now, but we're also mixing it with things like video game automation. We're going to talk about accessibility, which is really, really important in this 2025 here in the European Union. We're also having new topics like observability in testing, how some use cases are arising where you use your tests or your automation scripts to do synthetic monitoring. We're expanding with talks around the WebDriver ecosystem and much more. We have a really good agenda because we have a great set of people who helped us build the agenda. So I'm just here recognizing everyone who has helped to pick every single talk we have in our agenda. So the organizers and the program review committee. Um, I now just remember that I should add my picture there as well, but thank you to everyone who has been doing this work. If you want to check the agenda, it's over there, it's live. So you should go to seleniumconf.com/agenda. We have great keynotes, we have great talks, we have a panel, we have the State of the Union. Angie Jones is coming back to a Selenium conference. We're going to have Almudena Vivanco from a very interesting range of topics like performance. She's going to tell us different things about it. So this is an interesting keynote as well. So join us for the great content, for the conversations, for the good coffee and the great food and the sea view and the beach that you will have during the conference. If you want to register, head to seleniumconf.com/register. And if you want to get a discount, we're offering a 10% discount for the regular price. So you just use pre-conf webinar, that discount code, and then you're going to take 10% off from that price. Today, we have a super interesting topic, one of the pre-selected talks to be in the agenda, but unfortunately, we don't have enough slots for every single good talk we have. So the idea of this webinar is to give the opportunity to great people who are contributing to the ecosystem, to the industry, by sharing their knowledge, their learnings, and their experience. So today we have Suman with us. Suman is going to talk about one of my passions, which is infrastructure and scaling CI. Some things I've done, for example, in the Selenium grid and a bit with Appium. But yeah, welcome, Suman, and thank you for being here.
Thank you, Diego. Thanks for having me. I guess we can get started here.
Yeah, that's what I was going to ask you. I just wanted to thank you again for taking the time to share everything you're going to share with us today. So I'm just not going to delay this a bit more. I'm just going to give you the stage. Thank you for being here, and the stage is yours.
Thank you.
Thank you.
Thanks again, Diego. All right. Hello, everyone. Good morning, good afternoon, good evening, wherever you are joining this webinar from. I appreciate you all taking the time today. My name is Suman Sourav, and it's truly an honor today to represent quality engineering teams and tooling teams from Sony Interactive Entertainment as I share insights on scaling CI infrastructure for multiple QE quality engineering initiatives. My goal for this session is to provide you with some fresh perspectives and some practical takeaways that you can apply in your own work. I will target to cover most of my content in about 40 minutes and hopefully still have ample time for questions and answers in the end. So, with that said, I would like to give a quick introduction about myself. Beyond work, I try to balance indoor and outdoor activities in my free time, like exploring nature, capturing moments, and sometimes even doing silly things. Indoors, gaming is my way to unwind. See if you can recognize a couple of these popular games. I also like to tinker with music and share tracks on SoundCloud. Um, that little munchkin that you see in one of my pictures, that's my daughter. She's 1.5 years old, very playful, curious, and always keeps me on my toes. On the professional side, I am a staff software development engineer in test at Sony Interactive Entertainment. Um, I have been with the company for over 6 years now. I have spent most of my time working on automation, CI/CD, QA tooling. I'm based out of San Francisco, California, and I collaborate with teams worldwide. So, with that introduction, let's jump into today's session. We will start by setting the stage today. I'll share a brief overview of the evolution of the CI infrastructure at Sony Interactive Entertainment. I'll be using the term test infrastructure interchangeably. Um, think of it, think of this phrase as enabling testing in CI or test pipelines, test stages, whatever might be the right phrase that you use at your own work. Next, we will look into some scalability fundamentals, focusing on some key concepts and an architecture with some relatable examples. Then I'll share some key takeaways and lessons. And finally, I'll share what are my thoughts on the future of test infrastructure, hoping to create your own vision for what's next. Let's start by taking a moment to define test infrastructure to understand the scope of this session. Um, Core infrastructure um, is a vast topic. It spans a wide range of cloud platforms, tools, services, containerization technologies. While there are many successful stories of different organizations leveraging these at scale, one of the challenges lies in the fact that still we need to write and maintain custom code to be able to tailor these specific offerings such as tools, services, containerization technologies for our specific needs. So to ensure that this session offers a fresh perspective, I'll focus on some scientific approaches to building such custom code, especially for quality engineering initiatives in CI. So when I talk about test infrastructure, I broadly refer to everything within these curly braces. It's it includes CI platform, workflows, common reusable shared libraries, device farms, and other integration with different endpoints. Um, I will not be covering device farms in details today. But if that is of interest, do not miss my colleague Zach Hardy's session at the conference itself. They will dive into the evolution of device farms and share ideas to help scale device management systems globally. Uh, let's focus today on this area. CI pipelines, workflows, shared libraries. This is a very fundamental area that we as QE engineers, SDETs, and automation experts deal with. Quick note, although I refer to Jenkins as the CI platform in my session, but most of the most of the contents that I'll be sharing are interchangeable with any other CI platform such as GitHub Actions or GitLab CI, etc. So with that understanding of the scope, let's take a look at the evolution. So this timeline captures the test infrastructure evolution at Sony Interactive Entertainment. So to put into perspective, let's use the PS4 and PS5, PlayStation 4 and PlayStation 5 eras. Before PS4, uh, test automation was rare. Manual processes were largely the way to go. Um, During the PS4 era, we started with rudimentary test automation, quickly leveling our ecosystem for automation, QE tooling, and even taking test automations to Jenkins. As we approached PS5 launch and beyond, we had enabled testing in CI for all PlayStation applications. Of late, CI has been a major focus area, driving multiple QE initiatives and shaping how we scale testing today. I drove most of my contents today from that period, which I have contributed to and learned from. Um, so today, organized and structured testing in CI is integral to multiple projects at Sony Interactive Entertainment. Um, so let's take a moment to understand why we need a scalable test infrastructure. It comes down to three key factors. One, consistent environment. A reliable test infrastructure ensures consistency between different executions, reduces flakiness and other inconsistencies of testing in a local environment. Second, continuous testing. Um, as development accelerates, we need faster feedback. We need to know if a code breaks. Continuous feedback loops without additional manual overheads is what a scalable test infrastructure provides. And last but not the least, cost efficiency. It comes down to being able to scale test infrastructure efficiently and help reuse capabilities without reinventing the wheel for similar use cases. One of the challenges I have seen with flexibility is finding with scalability, sorry, is finding the right balance between flexibility and standardization. On the y-axis here, when flexibility is high, teams have the absolute freedom to modify their workflows. But as we scale and apply organizational processes, it can become very difficult to ensure compliances and it introduces duplication. Imagine um, that there are a large number of team in your organization, and each team implements its own ways to gather and measure telemetry, observability, basically. Imagine how difficult it would be to get a central data analysis and visualization out of that data. On the x-axis, here we have standardization, which brings efficiency, consistency, maintainability, and all of those advantages. But too much of it, and you limit the ability to for different teams and projects to adapt to their unique needs. So the key here would be to strike that balance, ensuring enough of both of these factors. And to strike that balance, in specifically test infrastructure, let's break down this space with some key questions that I'll try and answer through the rest of my slides. Questions such as how to implement pipelines with similar structure across different repositories while maintaining consistency, how to package reusable functionalities that many test pipelines need. How do we leave room for what I mentioned earlier, flexibility and customization? How do we define the whats and whys of test infrastructure and help teams get to a common ground? And finally, how do we roll out pipeline configurations to a large number of projects without creating much manual overheads? Let's explore some of these. It is a good idea to start with a generic test pipeline. The code snippet that you see on my screen is a very generic example, but pretty reflective of what I would think of as a test pipeline. It might have some pre-stages, some post-stages, and a couple test stages to run execute tests in CI. Depending on the use case, this CI pipeline might be it might be part of a larger workflow of the entire CI pipeline, or in some instances this can even be contained in its own Jenkins files. I use the term Jenkins file, but people more familiar with GitHub Actions, think of this code snippet as your workflow YAML file, for example. Now, let's say that this pipeline is the standard structure and needed by all teams, all projects in an organization. Well, we'll get to defining, we'll get to exploring the process of how to define this standard pipeline in a few minutes. But for now, let's assume that this is that pipeline structure that needs to be rolled out to multiple projects. Well, there are a couple approaches here. One key approach is we could make use of a scaffolding tool, and I'll explain what that is, or use this concept of pipeline as a library. Note that I mentioned pipeline as a library. Most examples that you will see in the over the internet would be pipelines and shared libraries. I'll explain this concept too. So we have two options, or in some cases, there could be a combination of both of these options, depending on the use case. So let's explore each of these approaches. Let's take a moment to understand this. To roll out pipelines across multiple repositories, we can use a scaffolding tool. A scaffolding tool basically is a tool that automates the project setup with predefined folder structure, files, configurations, makes it easy to bootstrap a project, get all of those initial boilerplate code, etc. Um, Yeoman, its shortened version is what I have mentioned as EO, is a Node.js based tool. It's a good tool that I have used for generating CI pipeline templates, source files, test directories in different projects and applications. There are various other tools, some open source tools as well, that can be researched online. But the way this tool works is that it takes as a plugin a generator application which defines the template and the overall folder structure and initial files for your project. A typical rollout flow would include that there are some rollout pipelines or scripts that work with this tool, take some inputs based on the needs, and they are able to create updates and the overall scaffolds that various projects in your organization might need. There are a couple key considerations here to make when using this approach. It's important to align on the repo structure, because that's how you start getting into the standardization aspect, and it simplifies scaling and maintenance. Scaffolding tool, in choosing which tool to use, it's important that the tool has the capability to both update existing structures and create new structures for new projects and existing projects. Also consider that it's not just that tool which is the only component, but there are several pieces to it, such as a rollout pipeline or a script, the generator application itself, and then additional inputs. So these may require maintenance effort in keeping these different components healthy. So consider that into the overall picture. This approach works best when there are a large number of projects that need to be supported, and there are frequent updates to the template code, configurations, etc. Quick recap. Key takeaway here is that use scaffolding tools to simplify rollouts of pipeline code and other code, in fact, to various repositories. It minimizes onboarding and manual efforts involved in that process. Let's take a look at the second approach here, what we can call as a pipeline as a library. This is ideal when multiple projects and teams use Jenkins files, which are very similar with only configurational differences. A common approach is to have a Jenkins file in each repo, but instead of duplicating the entire pipeline orchestration in each of these Jenkins file, that orchestration or the code for the pipeline and its stages is moved into a shared library, which is where the concept comes in, like pipeline as a library. And in this example that you see, I have a test pipeline.groovy on the top screenshot, which stays in a shared library along with other such pipelines. And a run test dot groovy, which could be a main test execution logic. Um, the users of this pipeline would basically just have a pipeline stub in their repos and call this pipeline as they would call any other functions in that shared library. So the whole and people familiar with other CI tools, maybe GitHub Actions, can think of this as the as how you would basically use a reusable workflow. Um, so this overall idea demonstrates that even pipelines can be moved into shared libraries. And why is this? When is this approach beneficial? um, in definitely couple places, such as, let's say the user repositories need to be kept cleaner, and there is no need to maintain the full pipeline logic in every repo. The second use case could be sometimes in companies there could be a small central CI and QE tooling team that supports multiple projects, and in this using this mechanism, a dedicated team can independently own, update, and maintain pipeline logic more centrally. Also, in cases where it's not possible to have a large scale rollout mechanism like we saw earlier in the previous slide. So these are some places where this approach is really beneficial. um, Key takeaway from this slide would be that pipeline as a library promotes maintainability and scalability. It centralizes pipeline logic into a shared library. And the whole concept of rollout here just reduces to the concept of a shared library version bump. Any pipeline updates need to be made, those can be made as a shared library update, and the users can just get the right shared library version and start using this. So far, uh, we looked at a couple rollout vehicles, and we started with the assumption that let's start with the standard pipeline. Well, how do we get to creating that pipeline? It's very much about the process here. And that's where one of the things that comes really handy is this overall process of request for comments, or RFCs. This is a very popular process that many open source projects even use today. It typically includes four stages. It starts with brainstorming with a small group of key subject matter experts or important stakeholders to define kind of a proposal. This proposal takes the form of a documentation, which includes links, details, architecture diagrams, and anything that's relevant to this proposal. And then it's subjected to reviews from key folks. There are a couple refinement that needs to happen, and when everyone agrees, there it reaches the stage of graduation. Graduating an RFC is just another fancy term to say that the RFC is now final and can be used for as a source of truth for further implementations. And any major changes to this to the requirements that caused this RFC, or new requirements coming in, can follow the same process as indicated by the orange arrows on my slides. So in short, RFCs are very much about the process of ensuring alignment, getting people to engage early, and also having a documented record of what's and whys of some decisions that were made in determining any course of action, and in this case, the pipeline overall architecture. So, quick recap. We looked at the need for getting aligned with different users, stakeholders, projects using some kind of an RFC-based process. We looked at a couple vehicles for rolling things out, for rolling pipelines out using scaffolding tools or using pipeline as a library concept. But there is definitely more to it. Let's continue exploring. Now, let's take a deeper dive into the pipeline. And a pipeline, as we know, is a collection of stages. So let's take a look at at a stage. Um, let's assume that our pipeline has these two stages. The intention of the first stage is to be able to run some functional tests, and stage two, to run some for performance tests. Um, it looks very simple in this conceptual example, very hello world-ish example, but in the real world, things are really very complex. You need to take care of different steps, such as creating a result directory or installing different dependencies, and maybe even supporting different languages, making sure the environment is eligible to do such operations, and maybe even finally sending data to various endpoints. So while it's very easy to look at the hello world example here, and think of replacing that, the commented lines with an entry point such as quote unquote run tests, or as a function there. um, it's certainly not the case, but managing these complexities efficiently with a very simple interface so that we can almost replace this, the commented lines, would be a key to managing, would be a key to implementing scalable pipelines. And let's explore how. And let's call that entry point, or the interface run tests. It could be that key to balancing between flexibility and standardization. If all test stages and test types use that entry point to execute tests, and everything that varies from scenario to scenario are parameterized. So essentially, this should abstract the nuances of the test execution from the Jenkins file, keeping the Jenkins files and our workflows more leaner, more scalable, that can be rolled out easily without much differences. So that's how we start getting into the aspects of a standard pipeline template. Let's explore this run test. It sounds very magical, elegant entry point, and the key to balancing flexibility and standardization, or so we think. When we started giving this a first shot, um, I think our response was more around getting less, and this is probably very practical to think of our first attempt as in line with some of the responses mentioned here. Less thought into the actual design of run test. See that the code grows organically with time, and in such with such a response, there are some side effects. We end up with a huge function called run test, and it is very complex uh, to maintain. So definitely there are opportunities here to improve. So that's where we get back to our coding and design basics. You can refactor that implementation with a more modular design, create smaller building blocks, and abstract logic and functionality out of that method. Maybe have other sub functions that are internally called by this entry point. So the overall goal there would be to then get improved debuggability, testability, and extensibility. This sounds great, but is it really possible? Let's continue diving in to see how there could be a way to achieve this. This is where I'd like to get to the fundamental concepts of setup, execute, and tear down. In most test automation frameworks, they are known as test lifecycle management concepts. And many test frameworks today support this at various levels: test method, test class, test sessions. Um, so you need to maybe initialize a page object before running your tests, use the setup hook. um, Need a cleanup, maybe bring down a service, or just clear some directory after test execution, use the tear down hooks at the appropriate level, of course. So um, why stop here? Why not use this concept for test stages and pipelines? Turns out it works really well. uh, Assume that we start using this concept in ci as well. Then our entry point, or run tests as I have been calling that, becomes a more structured sequence of setup, execute, and tear down. Much more modular, more predictable. So then naturally the next question is, what actually runs in these setup and tear down and execute at a test stage or a pipeline level? This is where I would like to introduce the term test steps. Inspired by Jenkins pipeline steps. Test steps really is a collection of or a sequence of custom steps or actions that need to execute successfully to run tests in the pipelines. For example, there could be a use case that needs to start a Docker container in the pipeline and install some dependencies that are needed by the test and maybe the test frameworks to successfully run the tests. These are example of some setup phase test steps. Similarly, let's say after execution of tests, the execution summary needs to be sent to a test case management system, or that some notifications need to be sent over emails or Slack. These are examples of a couple tear down steps. This sounds standard, right? Like someone could just then convert these English that I have mentioned here as examples into functions or methods, and then maintain that list as that standard list of different steps that every test need to execute. Well, it's important here to not forget that different use cases might need different setup or tear down or execute tests steps. For example, an API test would not need a real device, and so it will not probably need to invoke that step of going and grabbing a device from a device farm. But on the other hand, an end-to-end UI based test might need a device or a simulator. So it's important to have a mechanism that provides the flexibility for various types of testing needs, to be able to pick and choose which test steps need to be hooked together in a sequence, um, and executed. So this is the final piece of this puzzle here. And this is one of the last concepts before I put all of these concepts together into a possible architecture. The final piece of the puzzle is configurations. This is what makes this approach very scalable and flexible for different use cases. So which which test step should run can be passed in via parameters or configurations to this entry point called run test, which is used in a test stage or a pipeline. And that way, different scenarios that need different test steps can work together. For example, let's say executing a PyTest based APM UI test suite might require spinning up a Python Docker container in the pipeline, acquiring a target, which could be a console, a mobile device, or even a web browser, executing those APM tests. So, being able to create that PyTest command and then invoke that command, and finally sending some notifications at the end of execution. So with that example, one way to enable that would be to use configuration files. You could have YAMLs, JSON formatted files, whatever is the preferred choice in that you like. But essentially, the idea here is that we can enable configurations, or we can provide some configurations that help the framework enable these test steps together, so that we basically get a execution sequence of these test steps, and they get executed exactly based on what we have configured. So I think that's kind of all of those concepts that I would like to put together. And here is the big reveal: an architecture. So let's read this architecture from left to right, starting with inputs. And this is what we just went over. This could be configurations, which define which test steps to run. And then we have the entry point, which I have been calling as run tests. Each in this entry point, there are three phases: setup, execute, and tear down phases. And each of these performs a few fixed steps. They load the configurations, they map these configurations to define test steps. They pull these test steps together and create a valid sequence of functions to execute and execute these sequence. A couple additional things to note. Um, there could be reasons to add a module called business logic, which is what I is the term I have used here, for holding any kind of special rules such as predefined order of test steps. For example, let's say you need to grab a device from a device farm for testing. It's absolutely needed that you return it back to the farm after testing. So you would like to probably include some kind of a predefined order there and make sure that what is grabbed is returned. There could be other mutual exclusivity rules, like for example, if you are using A, then do not use B test steps. So these could be contained together in what I have put together as I'm calling as business logic, and it could easily come as an input to run tests to keep the run test structure lean and allow teams to define their own business logic. Or if there isn't much, this could also be a part of business. This could also be a part of the run test architecture overall. Depends on the use case really. And then the last piece here is in-memory data. So this is mostly what you can think of as at field notations or in-memory objects for maintaining thread specific data, facilitating interaction between different test steps. Maybe grab a list of IPs that you need to pass to another test step. So these could be this could be contained in the in-memory data. So with this overall structure, this entry point becomes modular, scalable, and definitely helps with flexibility. Let's explore next on how we could possibly scale this up for a new QE initiative with some examples. Um, Typically, when there is a new QE initiative or a mandatory process update, there are usually QE activities applicable. And if there is a CI component to this activity, then you would basically see this process as denoted by this flow in my slide. Typically need a RFC update to understand and align on what really is the need to update your pipeline logic and code. Then based on that RFC, you would need a CI infra update. And in this case, there could be some pipeline updates, and there could be updates, the test steps and business logic in the run tests architecture that we saw. With the CI update, there could be, then this updated CI would be available for early adopters for self onboarding. And after a couple refinements, a large scale rollout using some of the tools that we saw earlier would then make this overall feature generally available to all users. Some examples of such initiatives are things such as rolling out code coverage pipeline. Let's say your organization decides to understand the code coverage, or maybe even the performance of applications, or just maybe measuring the automation stability. So these are some things that definitely make sense doing in CI. And depending on the needs of an organization, such activities can spin up, and this would be a typical process to go about doing this. Let's understand this with a with one of these examples. Let's say measuring automation stability. Um, we can see how it's important to then define some of the things initially, like what even is automation stability. Get to an alignment on that definition. What is the right data structure that helps us define what's the level of automation stability. And also things such as what would be the right visualization, dashboarding, and other data analytics tools that we will need to use to measure this. All of these initial brainstorming and process definitions of various metrics, these could come together easily as a RFC process update. One of the key things then that becomes the responsibility of the CI test infrastructure specifically is being able to send that actual data based on what is aligned in this RFC. And that could typically mean, and I have used some examples here, um, maybe add a few test steps, such as collect automation stability data, which basically might be looking at parsing the Jenkins log, or maybe looking at your JUnit XML result files to understand what are the failures and the reasons of failures, putting that into a defined data structure, and then sending the data over a network to some data analysis platforms or stacks such as ELK, Grafana, etc. So adding these test steps and then enabling people to, um, enabling your projects and users to configure and hook these test steps together is totally possible with the example of run tests that we saw. So basically, the CI infrastructure then is a very defined process. You do not need to change everything, but be able to simply add new steps at the appropriate place and still get to reuse everything else that this architecture would provide. So this would be one way to go about measuring automation stability data. Similarly, if you want to, let's say, measure performance of an application, you'd probably think of initializing a service at a test step, call that a initialize performance telemetry service, and that could be a setup test step. Run your tests, and then in the end send data to a some kind of a statistical analysis module that helps you in getting that performance measured. So you can see, as long as you are able to visualize where what kind of a step makes sense in this overall flow of setup, execute, and tear down for the pipelines, you can easily implement that and add that as an extension to your existing test steps and help people and projects enable themselves with configuration based on whatever the need is. So, key takeaways here. We looked at a couple rollout tools, a pipeline as a library, scaffolding tools to understand how we can provide a large number of projects with some standard pipeline structures. We looked at the importance of having an RFC process, basically to establish that common ground, early engagement, and getting people aligned. We looked at some kind of a versatile, extensible test execution framework. I call it run test. I'm pretty sure people would have different names for such frameworks. Um, that's all. Um, or is it? What did I miss? I admit that while these concepts are really useful in getting us organized to get started, building that momentum to start building the scalable test infrastructure. But there is definitely more to it. And a couple of the things that I'll share next are basically not very specific to test infrastructure, but general concept that would apply for any kind of software development efforts. Let's take a look at just a few of these. Core infrastructure management. So, test infrastructure is not scalable if the core infrastructure is not well managed. Everything relies on a very strong foundation. So, for test infra need, the core infrastructure has some responsibilities, such as being able to provision the right compute capacity, node instances, etc. Being able to maintain, secure and updated infrastructure, plugin updates, images, etc. Being able to enable connections within, let's say, a corporate network. There are different endpoints, such as data storages, such as databases, other modules and services. All of these might be hosted in different endpoints, and allow listing these endpoints so that the CI code can interact with it. And last but not the least, monitoring to track usage and being able to analyze spikes and recommend optimizations. These are in most organization, you would typically see DevOps teams working on this aspect, and that's a very critical aspect. Next one is one of my favorite topics. As a SDET and a certified Scrum product owner, I think this could easily be a session of its own. But let me explain this further. Um, Too often, um, there has been changes in from the past, but still, unfortunately, too often, testing in CI is an afterthought. Oh, we have built a software, we need to ship it. Let's put a bunch of engineers together and build that pipeline. Let's ensure some tests run on that pipeline. Well, this thought needs to change. We need to break this mindset, because a well architected CI is integrating testing right from the beginning of product development is critical. This is even more critical in today's AI era, because the traditional testing workflows, which lean heavy on local testing, manual testing first, and automation later, will simply not scale. AI driven applications have need for high end validation environments that manual flows and our development PCs or laptops simply can't handle. So we need a CI first approach where testing and validation happen at scale in CI. Even the first commit to a certain repository of such an application arguably should have a basic CI already running. So to get there, we must treat test infrastructure as another user facing software or a product in its conventional sense. We should have a strong vision. Uh, we should have a good execution roadmap, uh, backlog and bug triaging management systems, preferably a dedicated team, and all other necessary ingredients that make for a successful product. Like any scalable software, test infrastructure needs long-term planning and continuous improvements. So reimagine test infrastructure as a user-facing software. Lastly, documentation. This is pretty self-explanatory, so I'm just going to reiterate a common phrase that many of us might have already heard. Good documentation is like a map. Without it, you may get lost in a sea of code. So just reiterating one of the initial concepts, that standardization and flexibility graph. So as organization scales, the temptation to standardize everything is very strong. And in the short run, this might work. However, as the needs of the organizations evolve in the mid to longer term, customizations creep in. And that's when suddenly whatever people would have worked so hard to standardize in the beginning begins to fragment. So it's very important to aim for that key balance, that sweet spot, especially for test infrastructure, where customizations can be provided and there is enough standardization for for creating a scalable and adaptable test infrastructure. Lastly, looking ahead, here are some of my thoughts for the future of test infrastructure. Um, the first point, decouple from CI platform. As unintuitive as this sounds, but there will be need with more popularity of different CI options such as GitHub Actions, etc. There will be need for an organization to support CI testing in CI for various platforms such as Jenkins, GitHub Actions, etc. This could be achieved by reducing dependencies. For example, people that use Jenkins today write a lot of CI code in Groovy. Reducing that dependency on Groovy and specific plugins to more portable platform independent languages could be a key. Second, collaborative effectively with cross function, especially in team structures such as where you'd see a very small infra and QE tooling team that supports a large number of projects. A big bottleneck could come in the speed of test infra, test framework, and tooling feature development. And this is where being able to collaborate effectively with a good inner source model for code contribution is very key to remove that bottleneck. Lastly, separating concerns. Today, CI pipelines often are bloated with all operational tasks that does not need to do with the source code of the applications. So, the original Jenkins philosophy, uh, the idea there is that pipeline should be simply lightweight, skeletal orchestrators, orchestration layer. So, taking that philosophy, the idea to have scalable test infrastructure with good abstractions and execution framework for testing in CI is needed. A good versatile framework such as run tests is definitely a strong move already in this direction. Next steps to think about would be to use some sort of a would be to basically think of not having every code written in your test steps directly, and those test steps would then unfortunately become very big. Instead, separate code out into dedicated services. For example, a test step that needs to grab a device from a device management system should not implement the whole logic of the device management system itself. It should just be a simple REST API call or a simple CLI call to get that device. So yeah, these are some of the things that I think would make sense in the near future. Obviously, there is one thing that I have left out in this slide, but that's everywhere. That's AI. So there are two folds to the aspect of AI in the context of test infrastructure. Test infrastructure should get more smart with the use of different AI modules, and test infrastructure need to support more AI based applications. But that's a whole big different topic, probably for another day today. So with that, extending credits where it is due. In addition to what you see here on my screen, I'd like to extend the credit to obviously my manager for enabling this, one of my colleagues, Michael, for much of the design thoughts on run tests, and in fact our larger QE and infra and tooling teams for directly or indirectly contributing to how we do testing in CI today. So with that, I would like to thank you all again for all your time. I hope today's session gave you some fresh perspectives on scaling testing in CI. And more than anything, I hope I inspired some of you to become thought leaders in this space of test infrastructure, make changes, push their boundaries in your organizations with CI, and someday come back to share your own stories. Okay, so I have covered my contents and I'll stop here for questions.
Thank you, Suman. That was very good. I feel that many of us ignore the importance of of the infrastructure in testing. It's like when things work well, we tend to ignore them, and this is one perfect example. Like when the water pipelines work well, when electricity is on, like this is test infrastructure. Like when things are working well, everybody ignores it. But when something doesn't work as expected, then people go crazy. So sometimes I feel that it's not enough to recognize that area. So thank you for sharing the different details you take into account when building that during your role at Sony Interactive and PlayStation. We don't have questions so far. I mean, I think someone was maybe surprised that you're using Jenkins at Sony. Um, so I guess that was like an interesting comment I found. In
I think
addition to that, yeah, sorry, go ahead.
I think Jenkins is a very popular CI tool at almost all organizations, with
Yeah,
definitely um, more interests growing on GitHub Actions, GitLab CI, and various other things. Yeah.
yeah, I think Jenkins is quite solid. I believe just it's a mix of like what is new, a bit of marketing, and so on. Also, sharing a comment from Oscar here in the topic of collecting metrics from Jenkins. There is there is an open source project that they use to export these metrics to Prometheus. So there is more observability in that field. So a tip shared for
Sweet, I'll
from
check this
Oscar.
out. Jenkins
And
export.
there is one question. I think we only have time for one question because we are almost at the top of the hour. So I'm going to read it to you. How do you handle, if you do, parallel test execution in the entire pipeline? I saw a retry mechanism, but nothing about parallelism.
Yes, the answer is yes. We do have parallel test execution in the pipelines. One of the things I think I should have, in the hindsight, highlighted of this run tests architecture that we went over is that we could easily have different stages in parallel and all calling multiple run tests in parallel. One of the key things that I mentioned in that architecture was interstep data, thread specific data that would work well when even when multiple um, parallel calls happen simultaneously across different stages running in parallel using this entry point. So to answer that question, yes, there are definitely retry mechanisms, and also there are ways to run this in parallel. In addition to that, also note that one of the key areas in that execute test step was really, creating a command that you can then delegate to the test framework such as PyTest, and you could have all
Mhm.
sorts of plugin into PyTests to kind of parallelize test execution. So there are two folds of answer to this question. The test framework can handle some parallelism, and also our run test framework, and the way you orchestrate things in a pipeline. Yes, that
Correct.
was a really good question.
Well, there is one extra comment. Somebody thanking us for the webinar. Thank you for your presentation, Suman. And with that, we're exactly at the top of the hour. If you can stay in the background for a moment, I just want to have a few words with you
All right.
to thank you.
Thank
But
you so
yeah,
much.
thank you everyone for being here. We're ending the stream right now, and we just want to thank you all for being here. Thank you, Suman, for sharing this with us. And until the next one, thank you. Bye.
Thanks all.